All right, here is another phase change diagram. So increasing temperature on the y-axis and increasing energy on the x-axis. So we've seen this diagram before in the simulation. The solid is, this is ice here. So ice in the solid form. So 0 is so this is the melting or freezing point. So depending on which way you're going. If we're going from left to right, we're increasing the energy, so we're adding heat. So the temperature, the solid, it stays solid, but it starts to vibrate more, right? It starts to vibrate in the solid until it gets to 0. And that's the point at which it starts to melt or freeze, depending on which way we're going. So we're going to the right. So we're going to melt. We're adding energy. But we get a combination of solid and liquid, okay? We get the solid and liquid. And then no other, right in here. So the bonds are broken, right? Bonds are breaking. And as the bonds are breaking, we're releasing energy, but we're not changing the temperature. So that is why it's this plateau. The temperature doesn't change. All the energy is for the broken bonds, right? Once we completely a liquid, right here, we can start to raise the temperature. So we can get it to hotter liquid, more kinetic energy. So the kinetic energy is rising right here, and it's in its liquid state. But when we get to 100, now it's the transition plateau between vaporization changing to a vapor or condensation changing from a gas to a liquid. So we're going in this direction. So this is our vaporization. So we're going, so you can see we have some particles of water and some particles of gas. So we're breaking those up, and they're breaking those bonds again, those intermolecular bonds, the bonds between atoms of water, not the interior bonds. This is the intermolecular. Inter means inside, or inter means between. I'm sorry, between. So we've got a water molecule that looks like Mickey Mouse here, and then we've got another water molecule that looks like Mickey Mouse, and we're breaking the bonds between those. That's the intermolecular. So that's why this stays at 100. We have to wait until all of this is gas, and at this point, it's all gas. Looks like this, and we can increase the temperature again. We can make this go to 600 degrees, and remember, burn a match. A match will light if we did this right, if we could add enough heat. So vapor, so this is the diagram that I'd like you to remember and how things are changing. Ice, we're adding temperature, we're heating it up. It's melting, and it's the transition between melting and freezing. Melting, so we have some ice and some water, all liquid. The temperature goes up till it's boiling point, and then we have a combination